Today's video will cover the basics of GDB, the GNU Debugger, mainly used for C or C++. It is portable, available on most Unix systems, and its command line shell is actually relatively easy to use. For a little background, here is our sample project, which consists of a file called main.c and another func.c with its header. Our main file used two functions defined in func. Notice the line I'm highlighting here should return a segmentation fault. It basically casts 0 as a pointer to int. Since normal OS doesn't have 0 as an address, this is a null pointer. We dereference it again and assign it to 1, creating our error. Now that we have the source file with an intended error, let's try to debug it. We have to compile with the G flag. After compilation, we type GDB into the terminal to get into its shell. To specify the program that we want to debug, run file command with the name of our executable or the program that needs debugging. Another way is to run GDB followed by the previous file name before entering the shell. Use a Q flag to disable startup text. This file command loads the symbols and the content of the source files which we will examine. Let's run our program with the run command. We can already see that the error is much clearer than we normally run, as it points out at what line does the segmentation fault occurs. The next command we're going to talk about is breakpoint, or B for short, which stops the program under a specific condition, allowing you to investigate everything up to a certain point in the program's runtime. It can be a specific line in your source file or the name of a function. Note that they can also be from other source files that you compile. Another good use of break is when we only need it under specific conditions, such as the value of a variable exceeds a threshold. To do so, we use break with if clause. It stops here since a is 192, satisfies the condition. Use info break to see all breakpoints when you have many breakpoints. Of course, you can enable, disable, or delete specific ones with this syntax where the breakpoint is represented by its ID or the order we created it. By default, running the delete command without arguments will prompt you to delete every points. After a breakpoint, you might want to check the value of a variable up to that break. Use print or P for short to print the value. You can use some C syntax such as pointer syntax or struct member syntax as showcased in here too. A similar command is watch, which tells you the value of a variable every time it is updated. In this case, we are monitoring our array to see how it changes. Now, after we're done with investigating, we can resume our program. As shown previously, we use the continue command to do so, which runs till it encounters another breakpoint or the end of a program. Note that just using run again prompts you to run from the beginning. Next and step are another ways to keep running. However, both of them execute a single line of code at once. The difference is that next removes subroutine like function call. To illustrate, we run next in step with our Fibonacci function. As you can see, next run each line consecutively, and it doesn't care about another function being called in that line. But step will, well, as indicated by its name, step into that function called in that line. Press enter will repeat the previous command, so you won't have to spam the up arrow. Backtrace prints a stack trace of function call, and you can think of it as showing how the program get into its current state. You can execute till the end of the current function right away with the finish command, then keep running your code like usual as I'm doing it here. And that concludes the quick and basic guide on GDB. Of course, there are more features than that, but what I've shown you should be sufficient for normal use case. If you want to learn more about this topic, check out its documentation or man page, which I have left links in description for that. Thanks for watching, and I hope I can be of help.